Okay, here's the lesson for section 1.4, elimination. So far in this chapter on linear systems, we've learned how to solve a linear system by graphing using the algebraic method of substitution. And today we're going to learn another algebraic method, which is called elimination. Okay. Let's remember a linear system. Okay, is when we consider two lines at the same time, so two linear equations at the same time. So let's say y equals 2x plus 1 and y equals 3x minus 3, let's say. Those are two lines. If we consider it at the same time, it's a linear system. Okay? To solve a linear system means to find the point of intersection. So if these are our two lines, those are my two lines. Oh, that's terrible. Let's make better lines. Okay, so let's say I won't draw the coordinate grid. So let's say these are my two lines right here. To solve it means to find the point of intersection, to find out where those two lines intersect. Okay, to find out the x and y coordinate of where they intersect. That's what solving a linear system means. Okay. Let's review what we learned last lesson. Okay, last lesson we worked with equivalent linear equations and equivalent linear systems. We learned, which will be very important for this lesson, this is what will let us use the method of elimination. We learned that an equivalent linear equation can be written by multiplying the equation by any real number. So if I have y equals 2x plus 1, if I multiply this whole equation by 2, so multiply everything in this equation by 2, multiply each term by 2, the resulting equation, so 2y plus 4x plus 2, everything's multiplied by 2. The resulting equation is equivalent. These are the exact same line. Okay, those two lines are exactly the same. If you graph them, they'd be right on top of each other. Okay. What else did we learn yesterday? We learned that when we add or subtract linear equations, we get a new linear equation that has the same solution. So adding or subtracting two linear equations results in a linear equation that has the same solution. So let's say I had 2x plus 3y equals 4. There's one line. And I had x plus y equals 2. There's another line. If I add or subtract those two lines, okay, it'll give me a new line that has the exact same solution. It'll go through the exact same point of intersection as these two lines. Okay, so let's just add them just to see. So 2x plus x, so add the like terms. That's why they're lined up like this. 3x plus add those, 4y equals 6. If I graphed this line along with these two, they would all intersect at the exact same point. So it might look something like that. They'd all intersect at the exact same point. Okay? So that's what we learned yesterday. Now you'll see how we're going to use that to help us use the method of elimination to find a point of intersection. Okay? So here's the steps for elimination. First thing you do, this is just to help organize our collecting of like terms when we're adding and subtracting. Get both equations in the form x plus y equals a number. Okay, so have x and y on one side of the equation, have the number on the constant on the other side of the equation. Okay. You then determine how to get rid of one of the variables. That's why it's called elimination. So we want to get rid of one of the variables. We want to eliminate it. Okay, so we're either going to add or subtract two equations to try and get us to eliminate one of the variables. Okay. We then add or subtract like terms in the equation to eliminate that variable we chose to eliminate. Solve the resulting equation for the remaining variable. Once we've solved for that one variable, we can then substitute that value into either one of the original equations and solve for the second variable. We'll then have the solutions to both the x and y coordinate of the point of intersection. Okay, so let's go ahead and see what that looks like. So if I want to solve this linear system by elimination, so I have 5x plus 2y equals negative 11 and 3x plus 2y equals negative 9. Those are two linear equations. Considering at the same time, it's a linear system. Solving it means find the point of intersection. Up until now, we could have solved it by graphing, but we know that just gives us an approximate answer, And it would be difficult for this because they're not in slope y-intercept form. We'd have to do a bunch of rearranging and there'd be a bunch of fractions. Okay? We know how to use substitution. I could isolate one of these variables, but none of these variables have a coefficient of 1 in front of it. Okay? So substitution wouldn't be easy. I'm going to have lots of fractions. So this is where elimination comes in handy. Okay? So what I'm going to do, I'm first going to make sure they're in the form x plus y equals a number, and in fact they are. I have x, y equals a number, x plus y equals a number, so I'm good. They're in the right form. Like terms are lined up with each other here. X's, y's, constants. Okay? Good. So now I'm going to try and determine how to get rid of one of the variables. Okay? I know I'm allowed to add or subtract two equations. If I add or subtract, it'll give me a new line which has the exact same point of intersection as these two. Okay? It'll go through those two at the exact same point. Okay? So if I add or subtract them, I'll get a new line. I can solve for the variable, and it'll give me a value for the variable that'll intersect at the same point. Okay? That's why I'm allowed to do that. So let's look at this. You'll notice both of these have a 2y. So if I subtracted these two equations, I'd have 2y minus 2y. The y's would be gone. Okay? So let's subtract equation 2 from equation 1. Subtract the x's. 5x minus 3x is 2x. 2y minus 2y is 0y. They're gone. I don't have to write anything. It's equal to negative 11 minus negative 9. Negative 11 minus negative 9 is negative 11 plus 9, which is negative 2. Okay? So I have 2x equals negative 2. That's the equation of my new line. Okay? Once I finish rearranging it, that'll be my new line that will intersect the same point as these two do. Okay? So divide the 2 to the other side to get x by itself to solve for the x. Okay? So I've done step 3 of add or subtracted the terms to eliminate the y. Step 4 now is solve the resulting equation for the remaining variable. Divide the 2 over. Negative 2 divided by 2 is negative 1. X equals negative 1. X equals negative 1 is a vertical line through negative 1 on the x-axis. Okay? So if these are my original two lines, I know they're going to intersect at negative 1. I know they are because when I add or subtract, it gives me the equation of my new line that intersects at the same point. So I know these two original lines are going to intersect at negative 1 on the x-axis. Okay? So all I have to do now is plug in negative 1 for x into either of the original equations. Okay? So plug in that negative 1 for that x or for that x, and I'm good. Okay? And it'll tell I can then solve for y and determine the y coordinate of the point of intersection. Okay? So let's go ahead and do that. Substitute it into either the first or the second. I'm going to sub it into the first. So I have 5. I know x is negative 1 at the point of intersection. Plus 2y equals negative 11. 5 times negative 1 is negative 5. Plus 2y equals negative 11. Okay. Move the 5 to the other side because I know I want to get y by itself eventually. Negative 11 plus 5. Okay. Negative 11 plus 5 is negative 6. Okay. Divide the 2 to the other side. Negative 6 divided by 2 is negative 3. So I have my y coordinate. I have my x coordinate of my point of intersection. So my POI is, remember it's an xy coordinate, negative 1, negative 3. There's my point of intersection. All done. Okay. Elimination is my favorite method for solving a linear system. Okay? If you get good at it, you can do it. You can do it very quickly. Okay. The hard part is just recognizing how you're going to eliminate a variable. So you have to do lots of practice questions to get good at recognizing how you can eliminate a variable. Okay. So so I did all of this on one page, so I don't need that second page there. Okay. So the first example is done. Let's do the second example. So solve using elimination. If you look at this equation here, so first step, get both equations in the form x plus y equals a number. They both are x, y equals number, x, y equals number. They're in the right form. If you look at these two equations, if I add these two equations, nothing is going to eliminate. Okay? If I subtract these two equations, 10x minus 8x is 2x. 4y minus negative 2y is 6y. So the variables aren't eliminating. Okay, nothing is eliminating. So this is where it gets a little trickier. Okay, remember, back to the beginning, we learned yesterday that we're allowed to multiply a linear equation by any constant, and it gives us an equivalent equation. So if we look at the second equation, if I multiply this whole second equation by 2, okay, multiply everything in that second equation by 2, every term in the second equation multiplied by 2 gives me an equivalent equation. This line is exactly the same as this one. Okay, let's rewrite this top one. Okay, 10x plus 4. Whoops. 10x plus 4y. 4y equals -1. Okay. Now, if I add these two equations, look what happens. 10x plus 16x is 26x. 4y plus -4y. So 4y plus -4y gives me 0y. Adding a negative, that means subtracting, so 4y minus 4y is 0y. So plus 0y. I don't even have to write that. 0y is nothing. Okay. -1 plus 14 is 13. So I have 26x. Oops, I forgot my x there. Sorry. That should be 10x plus 16x is 26x. So I have 26x equals 13. Get the x by itself, divide 26 to the other side. 13 divided by 26. 13 goes into both of those, the numerator and the denominator, so divide the numerator and denominator by 13 to get it in lowest terms, and that gives me 1/2 in lowest terms, a half. So x is a half. So that is the x-coordinate of where the lines will intersect. I know I'm allowed to add or subtract the equations. It'll give me a new line which will intersect with these two at the same point. That means that those two lines will intersect at x equals a half. I now just have to figure out the y-coordinate of where they intersect. I can plug x equals a half into either of the original two equations. At x equals a half, you will get the exact same y-coordinate no matter which equation you plug it into, because that's where they intersect. That's where they're the same at x equals 1/2. Okay? So I'm going to plug it into, let's do it into, you could plug it into this equation too, the one that wasn't multiplied by 2. If these two are equivalent, we'll give you the same answer. Okay? I'm going to plug it into, let's plug it into this first equation here, 10x plus 4y equals 1. So plug in a half for x, so 10x, 10 times a half, leave the rest the same, plus 4y equals -1. Solve this, half of 10, 10 times a half is 5. Okay, if you forget how to do that, multiplying fractions, any whole number is over 1, just multiply the numerators and the denominators. 10 times 1 is 10, 1 times 2 is 2, 10/2 is 5, 10 divided by 2 is 5. Okay? Plus 4y equals -1. That's a y, not an x. Make sure you can see that. Get the y by itself. I'm going to move the 5 to the other side. 4y equals -1. Bless me. 4y equals -1 minus 5. 4y equals -6. Get the y by itself, divide the 4 over, -6/4. Get that in lowest terms. 2 goes into 6 and 4. 2 goes into -6, -3 times. 2 goes into 4, 2 times. That's in lowest terms. The y-coordinate of my point of intersection is -3/2. So my point of intersection is 1/2, -3/2. Make sure you write it as an x, y coordinate. Okay? X comes first, y is second. Okay? So there's my point of intersection. Good. Let's do one more example. Okay, one more example where you're actually going to have to multiply both equations by a number in order to be able to eliminate a variable. Okay, so step number 1, I want to solve this by elimination. I have to make sure it's in the form x plus y equals a number. These both are. Okay, that way the like terms are lined up with each other. It makes it easier for collecting the like terms when we add or subtract. Okay. Next step, determine how to get rid of one of the variables. Okay, you'll notice none of these variables have the same coefficient. The x's have different coefficients, the y's have different coefficients. So adding or subtracting them isn't going to help us get rid of either of the variables. Okay? there's nothing I can multiply 4, well, excluding fractions, there's nothing I can multiply the 4 by, okay, to make it equal 5. And there's nothing I can multiply this 3 by to make it equal 4, okay? So what you're going to have to do, you're going to have to multiply both equations by a number to get them to have variables with the same coefficients. So if I multiplied this top equation by 5, okay, if I multiplied this top equation by 5, it would make this be 20x. Don't forget to multiply every term in this first equation by 5, plus 15y, okay, equals 13 times 5 is 65. Okay, and then I multiplied this bottom equation by 4. Okay, I'm multiplying it by 4 because I want the x's to have the same coefficient. So if I multiply this bottom one by 4, 4 times 5x is 20x. Okay, that gives me these variables of x with the same coefficient. I'll be able to eliminate them. Okay, I then have to multiply that negative 4y by 4. That gives me negative 16y equals by 4 here. So 7, 14, 21, 28, negative 28. Okay. Now, because both of these are positive, I can subtract these two equations, and it will eliminate the x's. 20x minus 20x is 0x. 15 minus negative 16 gives me positive 31y. Okay. Now, if I 65 minus negative 28, 65 plus 28, okay, that gives me 93. So I have 31y equals 93. Don't forget why we're allowed to add or subtract them. We're allowed to subtract the equations because it gives us a new line that has the same point of intersection, okay? And we're allowed to multiply the equations by a constant because that gives us equivalent equations. This line is exactly the same as this line. This line is exactly the same as this line. Okay, exactly the same. Okay, let's solve for y now. So what we've done so far, we put them both in the correct form. We determined how we were going to get rid of the variables. This is the most difficult kind where you have to multiply both equations by a number to get variables to have the same coefficient in order to eliminate them. So we figured that out. We then determined that we subtract in order to eliminate them because they have the same sign. If one of these was negative, if this was a negative 20x and this was a positive 20x, we would have to add them to eliminate. Okay, but in this case, because they have the same sign, we subtract, they eliminate. Okay, so then subtract everything. So we add or subtract the terms in the equation to eliminate the chosen variable. We're now solving the resulting equation for the remaining variable. So divide the 31 over. 93 divided by 31 is 3. Okay. So substitute that value into one of the original equations. Either one, I can substitute this 3 into that equation, or even into either of these because they're equivalent for y, and I'll be able to solve for x, and that'll tell me the x coordinate of the point of intersection. Okay? So let's go ahead and do that. Let's just plug it into the second one here because that's the only one I can see right now. So 5x minus 4 times y is 3, put it in brackets, so I know that I'm multiplying. Negative 7. Whenever you plug something in, always just put it in brackets, okay? That way you don't do add or subtract by accident, okay? So negative 4 times 3, I know I have to multiply by 3 because I remembered to put it in brackets when I substituted in for the y. Negative 4 times 3 is negative 12 equals negative 7. I want to get the x by itself, so I'm going to move the 12 to the other side. Negative 7 plus 12. Because 12 can be positive on this side, is 5. So 5x equals 5. Divide the 5 over. 5 divided by 5 is 1. X is 1. Y is 3. My point of intersection, don't forget my final step, point of intersection is 1, 3. Point of intersection is always an x, y coordinate. Okay? Good. So these two lines, say they look like this. Where they intersect is at 1, 3. Okay, so that's it for. That's it for solving using elimination. Okay, so now how do you know how to solve a linear system using the graphing method? okay, which gives us an approximate answer. You know how to use substitution, which is an algebraic method, and you know how to use elimination. Elimination is best. I like it best all the time, actually, but elimination is best when, especially when all of your variables have a coefficient that is not 1, like in the instances of the examples we did today. Okay? Any questions? Go to jensenmath.ca. Other than that, have a great day.